Next on our agenda is Dan Haddock. He's a principal engineer with INTERA. He comes from Rice University and is not a PhD, but he works with PhDs. So he's the guy that can interpret stuff as your PhDs are talking. He has a long history of working on municipal public water supply problems, any kind of water delivery systems, and he's going to give us a presentation now. Come on up.
All right, thank you. Let's see. There we go. All right. All right, great. Well, I'm going to be talking about optimizing well field management, and just a brief word about how I've kind of come to think about this is my background includes utility engineering. So I worked for a utility for 10 years and have really wrestled with this question: how to balance operating expenses and capital expenses. How much is the right amount of maintenance to get the most life out of your assets? And then with later work, like with INTERA and folks that know a lot about geosciences and groundwater modeling and aquifer dynamics, that's what has caused me to think more deeply about this problem of, how do you best manage what's really kind of a connected natural system with built infrastructure. Aim up high? Yeah. There we go. All right. So what I'm going to talk about is, there are a bunch of challenges that are facing utilities and also industries. Increasing challenges from a bunch of different directions. And what I want to talk about is how that utilities and industries can better take advantage of the data that they have and the knowledge that they have about how to operate their assets to do a better job of managing to those uncertainties. And then not just figuring it out, but then getting that data and those tools into the hands of operators that are actually making day-to-day decisions about how to run these systems. There we go. All right, it's kind of cut off a little bit there. But, so nationally, some of the challenges that utilities and industries are facing these are very well known, especially to folks here in Texas. Drought and uncertainty of supplies, resource depletion. One that's maybe less known to some folks that really impacts utilities is the increasing cost pressures for replacing infrastructure. Just lots of competing needs for investment that are driving up the cost of providing water service. And something that's known to the utility industry is, in the coming decades, there's going to be an increasing challenge to keep water service affordable for communities, especially smaller communities. So that's a challenge. Here in Texas, the state water plan lays out a lot of these challenges very clearly. You have competition for shared resources. There's reduced availability of surface water and groundwater supplies in different areas, environmental constraints, competition and negative impacts, the vulnerability of source water, and again, these competing demands for infrastructure investment, lots of dollars needed to address these problems. And then something else that's important, particularly to utilities, is that there's more and more need, it's more and more important to communicate with customers, regulators, and other stakeholders so that they have the confidence that the utility is managing those assets correctly. So the best first thing to do for a utility and an industry obviously is to just take full advantage of what you have. get the most out of the resources and the infrastructure that you already have. That could be conservation, of course, to just reduce the overall demand, but it could also involve optimizing operations to keep those wells efficient, optimizing maintenance to extend the life of those assets so they don't have to be replaced as quickly, and giving operators the tools that they need to really target the least life cycle cost of operating those assets. And that life cycle cost translates into rates, that customers are having to pay. The ability to defer or downsize capital investments can be huge. That can be a huge savings for utilities, so making the most out of what you have allows you to do that. And again, getting this information about how to optimize operation into the hands of operators so that they can use that to, day after day, hone in on this optimal operation. The interesting thing about groundwater assets is that, compared to other assets, they're really unique, compared to pipelines and things like that. Groundwater well fields involve the interaction of a natural aquifer system along with built assets. And they affect each other, and it affects the well field performance. And really, figuring out how to optimize that system requires an integrated analysis that's informed by knowing what's going on with both of those systems. And the insights into that interaction are really critical when it comes time to figure out what the best operation and maintenance strategies are for any particular supply. Common approaches to doing this, common approaches to figuring out how often I should clean my wells, what kind of maintenance I should do, often unintentionally wastes money. And what happens in many cases is that a noticeable decline in yield occurs, and then a utility or an industry will schedule some maintenance based on the fact that yields have already been impacted, or maybe pumps have failed. And in many cases, that means that they've already waited too long, and there can be actual permanent loss of efficiency in the wells that can shorten the life of those assets. And this is really kind of like driving, looking in the rearview mirror. And the impacts of this are that frequently the action should have been taken a long time ago, but you don't realize it until you notice the decline in production. And so the long-term effects of this are lower efficiency, higher energy use, shortening the life of your assets, getting years less life out of them than you might otherwise, and driving up life cycle costs and costs for your customers. And this picture really isn't of somebody looking in the rearview mirror to drive. I think he's probably driving 100 miles an hour looking backwards, but I like the look on his face. So, all right, generally, data is available. Industries and utilities have data in all kinds of different forms. It could be SCADA data, tests, written reports, maintenance records, well construction details, all kinds of different sources of data, but they're not organized or utilized efficiently in order to find these answers. Properly organized, though, this information, and generally my experience has been the utilities have a lot of information. It's just not all together. It's in different places. Properly organized, this can really be used to provide, to obtain good insight and to perform analysis that helps utilities and industries make more informed decisions about how they operate a well field and how they go about maintaining it. Like, for instance, it could be that the pumps that are installed in your wells were just the right pump for when those wells were new. But because seasonally water levels vary, well efficiency declines, there's well interference, different changes can occur. Those pumps might not be the right pumps for that full range of operating conditions. And the results of that are less efficiency, and in extreme cases, they could be operating outside of their range, and that could shorten their life as well. All right. This, properly organized, this data can really answer some important questions that are of real consequence to utilities and industries and the stakeholders and managers that they need to make requests of money to. Some of these questions might be, like can the average production from your existing wells be increased? And that might just be by ensuring that they're more reliable, that they're available when you need them to be. It might be ensuring that they remain efficient so that they can produce as much water as possible, where you want to, you don't want to pump them till they're dry, but, operate them the way that you want them to, but get the most water out of them. Can your overall energy costs be reduced? Are you experiencing pump failures, kind of unexpected or, failures of pumps sooner than you think that they should fail? Could something be done about that? And then the big question, this is the question that I used to wrestle with at my utility, is what is the right frequency of maintenance? And how do you go about deciding that? And through doing all this to optimize a source, is it possible to defer or downsize a planned capital investment? In some cases that can be a huge amount of money. If you're on the cusp of needing a new well field, new transmission main, if you can push that kind of investment off 5 years, that's worth quite a bit of money. The other important thing about finding these answers is it makes it a lot more easy to communicate why you're doing the things you're doing. And this is particularly important, again, from my utility experience, when you're talking about budgets. What's the right amount of money to budget for maintenance versus replacing wells? So here's an example of this type of approach for a specific client. This is for California American Water. They have an operation in Monterey, and they have a few different sources, a few different well fields, but they have one in particular that's in an alluvial aquifer. It's a very critical well field for water banking. They produce water from this well field during a certain season to inject in a different aquifer to then withdraw during the peak summer demands. So it's very critical for them that they produce and bank as much water as they possibly can within their permitted limits to have that available for summer demands, because they're not allowed to pump those same wells as hard during the summer. Very high demand on this well field. It's about nine wells. And because it was very high demand, their approach to maintenance had become somewhat reactive. They were pumping them hard until they failed, and then in an emergency, trying to go in and replace that pump so they could get it back online. In some of these wells, they had a very rapid loss of efficiency, which had significant consequences. And premature pump failure, again, caused by the loss of well efficiency. They had pumps failing, and again, this is a well field that they couldn't afford to have that happen. There were other related issues, water quality issues, including air entrainment that had something to do with how they were operating the well field and how it was performing. We did a number of different things involved in this. Because it was a critical well field, our initial involvement was to help advise them on some of the immediate pump replacements that they needed to do. So they knew that what they'd been doing in the past wasn't working out, So immediately it was helping figure out what are the right pumps for these wells. But then, once we got past that, we moved into gathering up all of the data that they had available. And it was really a wealth of data, a good bit of work to get it all together, but a lot of data. And did a little bit of testing on a couple of wells, did some downhole, like dynamic video surveys to see what was going on inside some well bores while they were being pumped to look at some of these air entrainment issues. Did an evaluation of the hydrogeology of the alluvial aquifer to get some insight into how it was performing and how that might relate to how it should be pumped. And then we engaged with operations, engineering, and their compliance staff to get, make sure that we were considering everything and talking to them about the approach that we were taking. We had really great results from this program. From this well field, we identified recommended improvements in pumping equipment and operating procedures that are on track to realize a 33% increase in their firm capacity from this well field, bring it up to about 11 MGD. This past year, after they'd made some of the initial improvements, they exceeded their record for banked ASR water by more than 50%. So it was a huge improvement in the amount of water they were able to bank. And for them, that was the money. That was the top goal. So far, seen a significant reduction in premature pump failure, and again, that's because the pumps are operating where they're supposed to. The loss of well efficiency was causing them to move into zones that they shouldn't be, and they were vibrating and failing soon. The estimated reduction in energy use was significant once they finished these upgrades. It's projected that they'll cut it by about a sixth on a per million gallon basis and save over $100,000 a year. And a significant decrease in the life cycle cost. Now it involves an increase in the amount spent on well maintenance, but it involves a reduction in the energy use and the projected costs to replace wells that were going to fail sooner than they should. And then we importantly identified opportunities to enhance their performance monitoring. They have all this data available, SCADA data, all this insight into their wells. It's kind of a shame to not take advantage of that and put that information in the hands of operators. Based on this analysis, we were able to show them that if you rather than clean your wells every 4 or 5 years, clean them every couple of years, lower life cycle costs, higher overall efficiency, and then we're able to turn around and provide the operators with triggers for maintenance activities, so that as we get this data organized and in their hands, on a more frequent periodic basis, they can see when performance is starting to decline, and they can schedule maintenance before it's too late. Stop looking backward and start looking forward. So with that, I'd be happy to, I think we've got a little time for questions. Yeah, I'd be happy to answer any questions that anyone has.
I have a question.
Yes, sir.
In you investigating wells to increase their efficiency, how often do you run into problems like insufficient well screening or poor well screening?
That can be an issue. I mean, the condition of them. You mean with the original construction that there just wasn't enough screen in them? Recent projects I haven't run into that, but I know I've seen that when I was at the utility. We had wells that we wished that we had completed differently.
follow-up, what's the largest concern in dealing with a regulator that your clients have run into?
From a
Utility perspective.
from a utility perspective, well, there's a number of them actually. You know, depending on where you are in the country, regulatory concerns could be. One of the values that this analysis had for California American Water, because they are regulated by the Public Utility Commission, so they have to justify why they are proposing to spend a certain amount of money on maintenance. And so this type of analysis helps them to show the Public Utility Commission that we want to invest this amount of money in more frequent, we want to increase our well maintenance, our well cleaning, because in the end it's going to result in lower rates for our water utility customers. And that's really what the Commission is after. And so being able to show them that's important. There could be other regulatory concerns related to, you know, just the soundness of the wells, or you know, interference with other nearby wells. But cost is the primary one, I think.
Are there any other questions? Oh,
Yes. Well, I think so you have a well field. You know that maybe you could be doing things a little bit better, but the money isn't just raining down on you. Is that? Yeah. So what I would say to that, and my initial advice for someone that thinks that, you know, they have a well field where they just feel like they could be managing things a little bit better. It's not very difficult to take a quick look, because all well fields are different. You know, you've got shallow wells, deep wells, different rates of decline and efficiency. There's a lot more value in this in some well fields than there is in other well fields. And it's fairly simple, just as a preliminary step, to take a look at the data that you have available. Take a look at, you know, how your well field operates, and to just do a quick desktop assessment of what the potential could be. And I think by doing that, that tells you what you need to know in order to decide how much farther to go. If there's significant potential, or for instance, if you happen to be a utility that's facing the need to invest millions of dollars in expanding your source of supply, there could be huge potential in optimizing what you can do with your existing assets. So looking at the potential benefits from better managing a well field, looking at reasonably what kind of gains could you expect by taking a more thoughtful approach to management. You do that up front, and then figure out what makes sense in terms of the next step. If there's a lot of data available, then it may be easy to do some good work with just that data. If there's not very much data available, or it could be that some testing might be recommended. Does that answer your question, sir? Yeah.
Are there any other questions? Dan will be around for a little bit.
Dan, we really do appreciate you coming and discussing this today.
All right.
Thank you very much.
All right. Thank you all.